a new way of scanning.
This is the new Tracket.
This is the Tracket 3D scanner.
It's kind of exciting, actually.
An absolutely brilliant tool.
No markers, no scanning spray, no special settings.
Which is amazing to me.
Oh wow, look how quickly that picked up.
Yeah, the scanner is extremely accurate. I love it when settings actually do what they say they're gonna do.
And this represents a really cool advancement in comparison to any of the 3D scanners that I've used before.
And I was really impressed with how well this works compared to every other scanner I've tried so far, because the model that I got out of this was basically perfect.
Finally affordable for the average consumer.
So it's nice that this is all automated. This is a process that would have previously had to have been done manually with most 3D scanners.
For years now, we've been hearing from professionals across the industry the need for a scanner that's going to dramatically cut the prepping time down. And one, of course, that doesn't require you to have to swap between scanners to scan small and large objects. And we know the largest time-consuming part of scanning is when you have to place markers on an object and remove them. So there's a drastic need for an optical tracking scanner because it doesn't require placing markers, and one that can both scan small and large objects. But the problem with the majority of optical tracking scanners on the market is they cost an arm and a leg. They're very expensive, so it makes it hard for the small business owner or individual user to justify to purchase one of these. And another problem is with a lot of these optical tracking scanners is the calibration process is required to be done manually. So this could cause the process to fail and cause inaccuracies, and worst case scenario, even require to be sent back to the manufacturer.
The key problems we identified when researching Tracket was that systems like these are vulnerable to accuracy drift and frame deformation. You see, this kind of target frame during assembly can develop cracks that can lead to errors, especially after transportation, shaking, or any impacts. Well, rather than trying to mitigate this assembly error, why not just eliminate the whole process like we did with this one-piece carbon fiber frame design? And since it's one piece, it won't deform, meaning you won't need to calibrate Tracket so frequently. Talking about calibration, we did something new with this, making the process much easier for you. We did this by creating an auto calibration system that uses 2 sets of dual-axis gimbals to automate the calibration. Now, you don't need to hold this calibration pole and rotate it anymore, which dramatically reduces the amount of operator input needed and the likelihood of user errors.
It is a 3D scanner that has both a camera to track the scanner and the scanner itself. Now, technology like this has been around for some time, but now it's finally affordable for the average consumer. This is the long-awaited Revopoint Trackit. Now, we've already gone ahead and went through the calibration procedure for the scanner, so I'm gonna skip through that. What's really nice about the scanner, though, is that the calibration is fully automatic. You have to move the tripods around, but the heads actually have gyros in them, and they calibrate themselves and move around, which is mind-blowing. I have not seen that in a scanner system yet, and I've owned multiple 3D scanners. Our drift Gia needs a cooling system. And because it's a drift car, we decided to put the cooling system in the back. Last week on the project, we made the roll cage. Well, at least we started it anyway. Another feature that I immediately like about the scanner is while you're scanning, the point cloud will turn from red to yellow to green to let you know that you have enough data. So this side is done. I can go ahead and just move to the other side. It'll lose tracking as I walk between the scanner and the cameras, but as I start scanning here, I'll pick right back up where I left off and be no problem, which is amazing to me. All right, there's our point cloud. I'm not worried about the fin area. I'm worried about the tanks and the edges for making our brackets and it fitting into a space that we need it to. But that is a clean point cloud. Usually you see a lot of artifacts or even like ghosting of like incorrect scanning. But because of the tracking system, it actually worked out pretty good. So I'm gonna process this, and then Tony, you're gonna be the litmus test to see if it's really
user-friendly.
Yeah, exactly. Tony's not inclined for technology, so
it'll actually be my first 3D scan. I've watched you do it.
Yeah, perfect. So Tony's gonna scan the fans then. I love it when settings actually do what they say they're gonna do.
It's like they designed it that way.
Yeah, see Tony scanning again, and I think it's old guy approved.
Yep.
All right, so we turned on large object mode and also the shiny metallic object mode, and it's scanning the exterior so much better now. So once I was done scanning everything, I also scanned the fuel cell to make sure I could put that somewhere in the chassis that made sense. You guys already know where I want to put it, so I scanned that so I could also throw that into the software. We're ready to drop this bad boy into the car. So the plan is to set the radiator in here, somehow kind of jig it up into place, and then we're gonna locate the holes to mount the brackets, and then we're gonna nut insert them just like we did with the brackets on the radiator. Holy guacamole, I'll tell you guys what, that 3D scanner made this very easy so far. And here's the final test. If this bolts in to the car, like, you know, I'm hoping it will, because I didn't test fit it yet because it's kind of hard to hold all three of the things in place in the air. Yeah, the scanner is extremely accurate. All right, this is it. This is the moment of truth. Were my measurements right? Was the scanner right? Was my CAD work right? Or am I gonna take this whole assembly, try to set it in the back of the car and have it not fit? Let's find out now. Oh, I can get this in here without dropping it. Fingertip clean. We'll get the rest of the bolts in and we'll check back in. It fits! My math was right for once, the scans were right, my CAD work was right for the most part. It fit, first try, and look how beautiful it is in there, guys. I'm so proud of myself. I can vouch for and say that even with my bad math, I was able to do a ton of fab work this week because of that scanner doing the math for me for the most part. So thanks for watching, guys. We'll catch you next week, and thanks for hanging in the shop with us.
We're going to take a look at the new Tracket from Revopoint, which is their most advanced 3D scanner so far. I will be showing you how 3D scanning works in general, why this scanner is different from the ones you might have tried so far, and why this is such a useful tool for designing and producing parts. This looks a bit different than the usual scanners you might have seen before, with the scanner itself being surrounded by this carbon fiber cage that is covered in marker points. That's also exactly what makes the Tracket so special, because it uses a very advanced tracking system that is usually only found in much more expensive professional models. So let me explain what I mean by that. Most scanners in the consumer or even in the semi-professional market rely on what's called markers on the object you want to scan, and those serve as reference points which allow the scanner to figure out where it is located in space in relation to the object. This is crucial to enable it to synchronize the data it's capturing with the data that's already been scanned, and this process is called tracking. While the sensors that capture the shape are pretty good nowadays, even on the cheaper scanners, the tracking is usually their main downfall, and dealing with tracking loss is basically a constant struggle for the user and can make scanning things very tedious. And needless to say, placing all these markers on every object you want to scan and then removing them afterwards is also just annoying and time consuming. So the Tracket solves all these issues by not requiring any markers at all. The device in here is called the Tracker, and it's basically an additional sensor with 2 cameras that you set up to overlook the general area you're scanning in. Instead of the scanner tracking the object, the Tracker will then actually track the scanner and communicate its position, so they've basically distributed the scanning and tracking to 2 separate devices. The huge benefit of this system is that it not only allows you to scan without any markers on the object, but it also results in much better tracking performance overall, which is why this solution is usually the standard on professional scanners that can easily cost 10 times as much. On most other scanners, calibration is done manually by the user by moving or positioning certain reference objects like this calibration pole. But Revopoint chose to both make this process more convenient and also take human error out of the equation by making this process almost completely automated. For this one I decided to scan my bench vise here. And it's also a good test for the scanner because it's pretty dark but also has bright metallic surfaces, which is something that many scanners tend to struggle with. I'm pretty happy with how the point cloud looks at this point, so I'm gonna stop the scan and hit complete, and now we're gonna start the refinement process, which really brings out just how much surface detail was captured. And this isn't even the highest resolution the scanner can do. I think it's a great result, and just for reference, I spent only 35 minutes on this entire scan from start to finish.
Hi, I'm Sam Blue from Streetcar 3D. I've been in the aftermarket performance world for several years now. I specialize in scanning, reverse engineering, and making performance parts for the S550 Mustangs, S197s, transitioning to the S650s, as well as some new edge Terminator performance applications. I've actually been using 3D scanning to actually help me in this world. I've been using Revopoint scanners for several years now, starting way back to like a Pop 2. I went from a Pop 2 to a Mini 1, and then I think after that it was a Range and a Pop 3, Inspire. I pretty much had the entire lot, including the Metro X, which is an exceptional 3D handheld 3D scanning device. And for today, I'm going to be demoing a new product. You probably see it right behind me. This is the new Tracket. This fancy guy right here is the new Tracket scanner from Revopoint. I'll probably scan this Mustang. So let's go ahead and see what we got. Okay. And we're just going to go ahead and get to scanning. As you can see, that's what we've captured. Now this is with a laser, so that's pretty impressive for me, with no markers. So just keep that in mind. That's really not that bad. All right, let's complete the scan. We got 23,917 frames. So guys, what do you think? I think that's pretty good, honestly. I'm hoping they might give me another beta version, and if they give me a newer version, I'll go and retry and see if it's better, but that's presentable to me. Something that's set up right here. I'm literally touching the Tracket. Pop the hood up, and what do we spend? Maybe 10 minutes scanning, probably 20 minutes processing, but I say that's pretty presentable, guys. And that's not the maximum resolution too. Keep that in mind. So anyways, this is Sam Lilly, Streetcar 3D. Hope you enjoyed this engine scan of a 4.6 liter V8 from a 2000 Spring Edition GT Mustang.
All right, the Revopoint Trackit is brand new on the market today, and it's a new way of scanning. So we're going to be taking the marker dots off of the object we're trying to scan, and we're going to put it onto that frame, and then we're going to have this thing watch us the whole time. Let's get at it and see how this thing works. It's kind of exciting, actually. It's not every day you get to try and play with new things. It's really reminiscent of the way the Metro X works, right? In terms of having it go, I'm too close, so it doesn't want that. We'll go to full screen mode here just so we can have a look at how it works. Again, if it's me and I'm doing this, I'm almost always looking at the screen. I'm almost never looking at the part. Like, I want to make sure I'm doing a good job. So where it's green means go. All right, so you've got enough points in those green areas to make it happen. In the blue areas, it's just starting to acquire a scan. Orange areas, not great. Okay, and we're back, and this is the meshed model. So before I move it in and do a proper screen capture, I just thought I would show you sort of what I'm getting in the garage here. Before I get a really good look at it. I'm just so happy with this. It's unbelievable. So this is 1 hour from start to finish. So from the first time I touched that scanner until the completed scan, 1 hour. That's amazing. That's so much less time than doing it any other way. All right. So let's move this into the computer and just have a quick look at it.
So all we're going to have time for today is just a quick look at that meshed model that we just produced in the garage. Now I've again switched over computers and we're going to have a look at the mesh. And I can tell you what I can see right away is this is pretty typical of that crossed blue laser light scanner, is it sort of gives this hashed look to everything, which is a pretty good sign that I'm going to need a few more points in that scan. But very impressed with the first go around. Again, I've only ever used the scanner one time. And these are things that you can settle out pretty easily here in the software. Like that's captured every bit as much detail. Remember, again, the engine block itself was it had some baby powder and alcohol sprayed on it, and then it had a shiny bell housing lopped onto the back of it. And most scanners don't like shiny things. This thing did not miss a beat covering that shiny object. So you really don't have to worry about scan spray and other things to get this to work. Very happy with the quality of the scan just at first blush. Okay, so let's cut it here, and we'll come back in a future video and go over some more of the scan settings and other things that are going to make the Trackit an absolutely brilliant tool in my garage.
Hey, I hope that's been helpful. That literally was the first scan that I did with the Trackit, right? Just got it a few weeks ago, only just got it set up the other day, and today was the first time we actually cracked it open, got it calibrated, and got it scanning. Instead of taking hours to do that scan of the engine scan, less than an hour. Never put a marker dot on it. Really happy with the quality.
This is the Tracket 3D scanner, and this represents a really cool advancement in comparison to any of the 3D scanners that I've used before. So this is a handheld 3D scanner. This is the handheld element, as you can see, and the primary difference with this and any scanners that I've used before is that this also has a tracking head, which you can see behind me there. Now, the massive benefit to that is that this tracking head locates in kind of free space the position of the handheld element that you're using here. So any scanner that I've used before has just located its position based on the part that you're scanning. That does that, but then it's also positioned by the head, which allows you to do really fast scanning of small parts and larger parts as well, and it's really super accurate. It also means that we don't need to use any markers when scanning because the tracking head knows the location of the handheld element at all times, and that makes things much easier and quicker to do. Because of the nature of the type of scan that this is able to perform, we can also scan various different surfaces like light and dark things, shiny surfaces, without the need for scanning spray, and that is again a massive improvement from anything that I've used before. There were various different things involved with the calibration of this scanner. Now, there's quite an involved calibration process, but it's actually really simple to work through. The software guides you through everything that you need to know in order to get things set up. So you've got these two gimbals that control the calibration pole, which you can see me setting up here, and also the tracking head as well. The two of those move around in various different tasks throughout the calibration process that we'll see in operation in just a minute. So you get those set up on a tripod, and the tracking head lives on the largest one of those. You can then connect all the USBs, and the really nice thing with this is that the USB connections screw in with these little lock-in pins, which is brilliant for when you're moving things around, especially in a workshop environment. You don't want those fragile cables being pulled out. You can then start the calibration process, and as I mentioned, there's a number of different functions that involve moving things around, scanning different parts of the calibration plate. So we start out primarily with just an accuracy check, and then we do a calibration process between the tracking head and this calibration pole. As you can see, it's all automated movement. So the gimbals do all the moving of all the different parts, and they register the position, I guess, between the two components, and you just sit back and do what the software tells you. It tells you to move the tracking head into various different positions and locations, and tells you when you're perfectly aligned. And then you just click next, and it undertakes the calibration process for you. It's a pretty cool thing to see, actually, this kind of tracking heads turning around and looking at all different angles, and the pole is moving on its own as well. This is a process that would have previously had to have been done manually with most 3D scanners. You have to stand there and turn the tracking pole yourself. So it's nice that this is all automated. You can then change over to the handheld element of the scanner, and that does a similar process. It registers and calibrates itself in relation to that board, but then also in relation to the tracking head, which is across the other side of the room and monitoring the correlation between all three elements. So in this video, I'm going to be 3D scanning this supercharger here. This is going to go on my boat a little bit further on down the line, and having a 3D scanner, that is going to allow me to place that alongside the 3D model that I've already got of the engine for my boat. And it's going to allow me to position that, design brackets to get it fixed in the correct place. I'm also going to 3D scan the inlet manifold, which will go in place of what I've currently got. That's also going to allow me to design the intake transfer that goes between the two, and position everything, make sure that we've got all good clearances. And this is going to hopefully showcase a really good example of what we can use 3D scanning for, and also how awesome this bit of kit is. So this is what I'm scanning. First of all, you can see it's got quite a complex geometry to it and a range of different surfaces. We've got some dark and some light, so this will test the process well. So once we've done the first bit of scan, we can take a look at the part and see what's going on, and see what we've captured. And at this stage, we can drop back and continue scanning if we need to. Now you'll notice there's some fairly large gaps on the bottom edge of this component, which we couldn't reach due to the angle that it was sat. So now what we're going to do is turn the part over, and we're going to do a second scan from the other side, and then we can merge the two of those together in the software, so we've got complete capture of every angle from this part. So I set up a second scan and then scan the other side of the supercharger. As long as we've got plenty of overlap between the two, we can create a really good alignment between the two scans. One of the really nice features of this scanner is the fact that the frame that surrounds the scanning head is actually a single piece carbon fiber molding. Now that makes this really dimensionally accurate, so it means that you can maintain its tracking position really well and reliably, but it also makes it really lightweight. So although this looks like quite a bulky thing to be holding whilst you're scanning, it's incredibly lightweight, and that makes it really nice and easy. So once I've finished getting a scan of the second side, I do the same cleanup process again, just get rid of those little bits of noise, and then we can merge the two parts together. So there's a look at the second side of the scan after we've undergone the same kind of cleanup and hole filling process, certainly for the majority of parts that we're going to use. Then we can use this merge function. So we select the two separate scans, and you can see that one here is yellow and one is purple. And the software is going to automatically look for common features between the two of those and create an alignment between the two. You just click that button at the top there, and it automatically puts the two together. We can then blend these into one single mesh together, and this is what the part looks like once we've done that. So you can see we've got a complete scan now of all the faces of the supercharger, and we've got our complete 3D mesh model. So this can now be exported and used in external software. Using the exact same process, I've also scanned the inlet manifold that I'm going to use for this engine, and here's a quick look at how that mesh comes out straight off the scanner post cleanup using all the same tools that we've just done on the supercharger. So what can we actually do with these files? Well, let's chuck them into a CAD package alongside the engine, and we'll see what we can actually now use this information for in a real life scenario. And this is the model of the engine as we've currently got it designed. So I can get rid of the existing inlet manifold setup and then insert the 3D scan for the new inlet manifold. So there's a little look at the finished design. You can see that those scans imported into the 3D models allowed me to place those, work out exactly where they're going to go to fit correctly with everything else that's going on. And then it's allowed me to design the final component that connects the two of those together. So really great illustration of what we can use 3D scan data for in a real life design scenario. And with the accuracy that comes from that 3D scan, this makes this really quick and easy process. Scanning without markers is a massive efficiency increase. Normally with a 3D scanner, you would need to have at least 4 markers within the field of view of the scanner at all times. So on a component like this, we'd have to put 20, 30, maybe even more markers all over it. That interferes with the geometry of the part. It creates a lot more work placing them, and it's generally kind of slows you down. So being able to eradicate that step from the 3D scanning process is really good indeed. I think you will find that given the technology that is included within this scanner, the price point is incredibly competitive with other ones on the market. And as you've seen, it's really versatile with all different surfaces, different scanning modes, and it's a really great bit of kit. It's certainly a massive improvement to anything that I've used before.
Over our first decade, Revopoint has developed mature, reliable production lines and quality control processes. Before each unit is shipped, strict quality control procedures, such as 30-step accuracy checks, are performed to ensure that every unit meets the highest standard. We thank you all for your support and feedback over the years and offer special thanks to our beta testers for their time and effort. As a user-facing company, your input guides us on our mission to make 3D scanning technology accessible to all through reliable, cost-effective, long-lasting, and easy-to-use 3D scanners. Thank you for your time, and we hope you'll join us for this important step forward with the Revopoint Trackit.